Graham, you've brought us to Orwinga Wharf because this is where one of your tsunami gauges is.
That's right.
Doesn't look like much.
No. So there's a stainless steel cylinder coming down, bolted from under the wharf, directly underwater, and the tsunami gauge itself is actually sitting underwater. And what's under there looks like this. This one's actually from Rowell Island, but it's just a tube, and inside the middle of the tube, we've actually got a couple of pressure sensors in there. You see them side by side, and they're both doing the same thing. It's just to check that they're both working. And they measure pressure in the water, which is the weight of water above the sensor, and that tells us what the water height is. And these are tsunami gauges. They give us live data. They're like a tide gauge, but they're much faster live data.
Right, and we can see that data on GeoNet?
Yeah, you can go onto GeoNet and see that live data coming in. You can see it sitting on top of the tide cycle, or there's also a version where we've deleted the tide out and you can just see a straight line, and you'll be able to see a tsunami coming in on that. And also at these stations, we've got typically our seismometers. So these seismic sensors pick up earthquakes and how much the ground's shaking, and then we've also got GPS sensors, and this is a GPS antenna, and these are ultra precise. They know where they are to the nearest millimeter, and they give us precise GPS time, which we need for the seismometer. So that's a typical sensor package, and actually these are all around the Pacific through our partner agencies. We run these out of GeoNet, but we can access the data from everywhere around the Pacific.
Right, so I can see this equipment here, but do you have exactly the same equipment way out in the deep ocean?
So out in the deep ocean, we've got what we call dart buoys, which are the same concept. They're a pressure sensor on the bottom of the ocean, talking by sonar up to a floating buoy, and then by satellite back to us, and we can watch that data. So if there's an earthquake, the seismometers will pick the earthquake up and we get a feeling for how big it is, and we can forecast the tsunami. Then when it hits the tsunami gauge, we can actually sense how big the wave is. If it goes over a dart buoy in the deep ocean, and we maintain those out in the deep water, we can calibrate it more. And that helps us say how big a tsunami might be to emergency management, and they can decide on how big an evacuation to send out in the public alert to the public.
Okay, so it's giving a lot of information, and in some cases for those further away tsunami, it's giving warning. Right. But we still need to be aware that we may not get that official warning.
Yeah, so the key thing here is this is for tsunami coming from far away where you might not feel the earthquake. If you do feel a long or a strong earthquake, hard to stand up or longer than a minute, you've got to evacuate immediately. All of this gear is just for the other tsunami coming from far away where you might not feel it.
Right, excellent. Thanks, Graham.
Cheers.